Um, Hello, everyone. Thanks for joining today. This event is brought to you by Data Talks Club, which is a community of people who love data. And we have two types of events. So this event today is a technical, more technical event, like a webinar, um, where we talk about technical topics like we had data versioning explained, model monitoring, and today we'll talk about an end-to-end process for rolling out a customer service bot. But we also have less technical events, which we have on Fridays, and they are about it's just like more a conversation than a presentation, where we just talk about a particular topic. Last Friday, we talked about developer advocacy. This week, we'll talk about open source and MLOps. And the next week on Tuesday, or during the time of our usual technical event, we'll have another conversation about feature stores. And then in February, we will have a conference. Each Friday, we will have a track about different topics, and there will be 4 talks each day. So we'll have a talk about machine learning use cases, then processes and product, then career and data, and then we'll have a talk about machine learning production. And this conference is supported by our friends, Machine Learning Ops community and Aurelia. So you can go on our website, check it out and register if you're interested. And today we will use Slido for questions. So if anytime during our conversation you have a question, just feel free to use Slido, ask your question, and then at the end of the talk, we'll go through these questions and answer them. I will send the link right now to chat. And Neal, the floor is yours.
Great. Let me share my screen. I think you need to give me permissions to do that.
Okay.
Oh, okay, cool. So all right. Everything looking good on your side? Ready to go? Great.
Yes.
So thank you very much for having me, for inviting me, Alexi. My name is Neal. I am a director of machine learning at Monzo Bank in the UK. And for those of you who don't know, Monzo is an app-only bank based in the UK and also recently-ish launched in the United States. And now in the United Kingdom, we have just shy of 5 million customers. So I joined about 3 years ago when the company was getting its banking license, and we had about 500,000 customers. So it's been quite a crazy ride as the company has grown so quickly. For today's talk, I want to share a bit about a project that we did in 2019 related to chatbots. And there's sort of 3 broad areas that I wanted to cover: what we were trying to achieve, measuring it, designing, building, iterating, and then finally a quick note on how we ship the system. The main things at the top of my mind as a person leading a machine learning team is how we can accelerate the path to production, and also how we can work collaboratively across many machine learning scientists when working on a big system like this. So yeah, those are the 2 things that I hope will stand out in a lot of the decisions that I made along the way. So let's frame the problem a little bit. I mentioned that Monzo is an app-only bank, and so we don't have any physical branches that customers can walk into, and everything they do is via the app. That includes customer support, and so if customers have a problem, they can call us. they can email us, but primarily what customers will do is they will get in touch with us via the app through a chat functionality. And when thinking about the types of questions and problems that customers come to us with, I broke it down into these 4 quadrants. So there are cases where customers just need some information, and this is information that we have already available in the app, and maybe we need to just help the customer find it. So a common question there could be, does my card work in Germany or in Italy? And so on the other hand, there could be some informational questions that customers have where that information isn't readily available in the app already today. So for example, customers can send us in a check, and right now you can't see the exact status of the check in the app, maybe one day. So sometimes customers get in touch with us and say, what is the status of my check? And in those 2 top quadrants, it's customers really seeking information. On the bottom half is customers who actually need us to do something for them. So we have an example, can I have a bank statement? And this is something that customers could do themselves in the app if they found the right button to click. But sometimes they don't find it, and so they get in touch with customer support saying, I need a bank statement. And then finally, there's the stuff that they ask us where we need to do internal investigation. So for the example I put here is a customer getting in touch saying, I don't recognize this transaction. And maybe that needs us to get a financial crime specialist involved to look into the account. So for this work, we were focusing really on this first column of questions. So the types of questions where customers need information or they need an action, but the key thing is that these are the types of informational or action questions where self-service is a viable option. There's 2 reasons for this. First of all, the quickest way to get customer service problems resolved is if you enable the customer to solve them themselves. And then the second good side of that is that if we can remove a lot of these types of questions from the inbound that our customer service team faces, then their time is better spent doing the stuff that we really need them to do. So how do we get a sense of the size of these different types of problems? So behind the scenes, when a customer will get in touch with us, we will chat with them in the app, and we'll be logging data about everything that's happening along the way. And usually when that conversation is coming to a close, we'll get the customer service agent, internally we call them COPs, for customer operations, and the COP will tag the conversation to indicate what the topic of that conversation was. So we can start to quantify these 4 different types of interactions that we have with customers, how many of them are getting in touch with us overall, how many get in touch with us by different types of topics, and how many of them are using the self-service features as opposed to getting in touch with us about a specific type of problem. So the example I gave earlier was we have a way in the app for customers to download a bank statement. We can compare how many customers are downloading bank statements versus getting in touch with us and requesting a bank statement. So these are all the ways that we can quantify this type of problem. And we decided that specifically for that self-service column, we thought it would be great to run a few experiments on to help to automate this process. So the very first thing that we did was very much guided by speed. Let's try and get something out, an MVP, into customers' hands, see how they react, and measure how impactful it is. So in the app, we already had a search feature. This is a little bit of an old screenshot, but broadly what it looks like. So the customer can go to the help screen in the app, they can search, we show them some search results, and then usually we used to show this I can't find what I'm looking for button where customers would then go into chat. But one of the issues that we had back in 2019 was that customers wouldn't always try searching before getting in touch with us, even if the information was there. So it was nearly, they would just sort of default to getting in touch with us and saying, how do I change my address? Even though if they would have searched for that, they would have found the answer right away. Under the hood, this search model is basically a text encoder that is looking at the cosine distance between the encoded query from the customer and the encoded representation from about 1,000 help-related articles. So the very first thing that we did was move our search functionality so that it would also be available in the chat screen. So here's what it looked like. A customer would come into the chat screen and they would be prompted, asking them to give as much information as they could. The customer would then send one or more messages, which has their query. And after a while, we would trigger this search system with those with that query and give them back the top 3 results. And so in this example, you can see I'm going to Mexico. Are there any fees for using my card in Mexico? And the top suggested article is fees and charges abroad. From there, the customer could click through to the article, and then if they come back to the chat screen, they could manually close that chat, or they could decide they still needed help and wanted to go through to customer service. So why did we take this approach? Broadly, because it laid the foundations for building all sorts of chat experiences. So from a product engineering perspective, there's actually a lot of very small details that we had to figure out that were very not trivial to figure out in order to build automated functionality into the chat screen. So a very simple one from the sound of it is detecting when the customer has stopped typing in order to trigger those recommendations. And we also had to add support for new types of chat bubbles that can show links. And then one of the most debated decisions that had to be made was, what do we do when customers sort of abandon the chat screen when they are mid-flow while interacting with the bot? So it was actually quite a common occurrence, because if the bot would recommend a help article that had the answer that you needed, you would just go read that article and then you would never come back to the chat screen. So the engineering team implemented this auto close where your chat would be closed if you didn't come back for 2 days, approximately. So that was from the engineering side. From the data science side, making this sort of change forced us to set up all the metrics that we needed. So if I jump back, you can see that our core metric was around these buttons here at the bottom of the window. And we were looking for how many customers are clicking that I found what I was looking for button, how many of them are interacting with the bot and then not progressing to go and talk to a human. And the thing that was my favorite part was that we didn't need to ship any new machine learning systems in order to run this. If we can get functionality out of an existing ML system without needing to build a new one, that's a fantastic win for my team. The one thing that we did do was, at that time, we were exploring the Hugging Face library. It went by its previous name at the time of PyTorch pre-trained BERT. And by switching out in-house encoder network that we had trained from scratch with a fine-tuned BERT model, we actually managed nearly a 10% increase in self-service rate on these 3 article recommendations. So a lot of pieces moving at the same time of product changes, analytics updates, and machine learning experiments. So I covered that. Let's jump to the second iteration. So broadly, we reached a stage whereby now we found that nearly 20% of our conversations were being resolved by customers themselves, by finding the articles that they needed. So we all sat down together and we thought, could we actually do better than this? And the key insight here is in the picture is that the bot experience that we built puts all of the burden back on the customer. The customer would write their query and our bot was pretty dumb and would say, hey, here's some 3 blue links. Do any of those help you? So we had observed that there were some customers who were bouncing back and forth, look at the first one, then go look at the second one, go look at the third one. And so although now this pattern is fairly widespread in customer support, I feel it sort of patching over a problem and not sort of getting creating the best possible customer experience. So by returning to the data and looking at what customers are talking to us about, we could identify a bunch of topics that had these 3 unique criteria. So the first criteria being they were valuable for us. So that means a lot of customers would ask us about this. An example being, I've forgotten the PIN code for my PIN number for my card. The second criteria was that they were eligible for self-service. So customers can see their PIN code in the app if they go through the verification flow. And then the final criteria was we can train classifiers to detect this type of topic. So what we ended up building looked like this. And it's a very, it's a minor iteration on what you saw before. So again, the customer comes into the chat, they get prompted to give as much information as they can. That prompt sounds like, oh, just a sort of introductory prompt. It ended up being kind of critical for this application because a lot of customers who didn't receive that prompt would just say hello, and then we couldn't classify any topic out of a hello. So we would prompt them for information. They would give us their query. This is a toy example. My dog ate my card. And then that would be sent to our classifiers. And in this case, we predicted that the customer actually needs a replacement card. And so instead of giving them the 3 blue links saying, maybe some of these help you, we say, okay, here's how you order a replacement card. Just click this button. And then again, we slotted in the self-selected chat closure buttons. So the critical difference here is that now we've gone from a ranking problem to a classification problem. And there were about 20 or so different topics that we had identified using these 3 criteria that would be relevant for us to be giving outright answers to. But again, we didn't want to go away and spend however many weeks training a 20-class multi-class classifier. So we started with one. I don't remember exactly which one, but I think it was this card replacement topic. So we went back to the Hugging Face library and we fine-tuned BERT again, this time on, with this binary classification task. Is the customer asking about a card replacement, yes or no? Instead of sending this out to customers right away, the traditional way that we deploy these models is to deploy them into what's called shadow mode first. And what that means is that the model is there, it's in production, it receives data, it spits out predictions, we log data about the predictions that it's making, but we just don't act on them. So for about a week, this card replacement model was there in production, but customers were still getting the 3 blue links. And then we tied the system in to our data labeling internal system so that we could measure how well is this thing doing. Our goal being that if the accuracy would look good, then we could actually turn it on for customers. So this is where we ran into a kind of classical problem in machine learning, which is that the offline metrics that we had when we were training these models was looking much, much better than what we would actually achieve in production. And if you've worked with production ML systems, you won't be surprised by this at all. And it was actually, it triggered some sort of deep investigations for these different topics from my team. Particularly in some cases where in the offline stage it looked great, but in the online stage when we were labeling these things that had been predicted live, they looked awful. In general, the underlying reason for this was not the models, it was the data. And again, sort of very unsurprising thing. What we found is that there was quite a lot of inconsistency in how our agents would tag conversations. And this had nothing to do with them doing things wrong, but more about different interpretations of the same thing happening. So a very simple example is if a customer gets married and wants to change their legal name, then some agents would tag that as updating the details. And we had interpreted updating details as changing your address, your home address. And so we had a lot of noise in the data. So what did we do? I mentioned earlier, we have this internal system that we use for labeling data. And this is a screenshot where I've just pasted on top of it a fake query from myself. And it looks like this. So the internal UI asks us, is this customer asking about cash deposits? In this case, the customer was asking about a savings account. So we would say no. And we would do that for about an hour a week in the whole team, and label some of the latest predictions that have come in. And that allowed us to feed this back into our training pipeline. So overall, the way the training pipeline looked was we'd start with BERT. We would fine tune it with huge amounts of this noisy tag-based data. And then we would take the most promising models from there and fine tune it again with the smaller sample of relabeled data that we had labeled ourselves manually. And this allowed us, I mean, this was the trick to getting the metrics to line up much closer between offline and online. And I guess it's no surprise that that in these production environments, fixing the data will give you bigger returns than tweaking the model. So I mentioned that we tried it with one topic. And so we rolled it out as an experiment in shadow mode. It looked great. We fixed some of the data and retrained the model. And then we rolled it out visibly to customers. So they would get the actual answer from the bot. And that looked great as well. So it increased the self-service rate. And so the next question was, okay, now it can answer one topic. Can we get it to answer two topics? Can we get it to answer three topics? And the key thing here is that we wanted to build on this model incrementally. We didn't want to have to retrain it from scratch every single time that we wanted to add more knowledge into the system. We wanted to be able to be a bit reactive if there was a new topic that came up, that we could quickly train a model and add it in. And as you may be aware, if you have two machine learning scientists who are working collaboratively, it's very hard to get them to work collaboratively on the same exact model. And what you'll see happens more frequently in those cases is they will end up working in a kind of Kaggle competition style where they're both training for the same outcome, and then they need to decide whose model gets to go into production. So this is a wider, collaboration is a wider unsolved problem in machine learning and industry. But what we did was we changed our approach to machine learning in order to foster more collaboration. So the way we did it is to take advantage of the fact that Monzo as a bank is built on as a microservice architecture. And so here's a tweet from one of our staff engineers where he had an animation of a request from the mobile app all the way on the left, and all of the different microservices that request will go through. I don't have time today to go through all of the ins and outs of our production infrastructure, but I have linked below to this talk that Suhail and Matt gave at QCon, and I highly recommend it. They talk about how the whole thing is set up. So what that means for us as machine learning scientists and machine learning engineers is that we will ship individual binary classifiers as their own microservice. And then, so in this case, imagine that classifier A is the card replacement classifier. And then we want to add in a new topic into the system for customers forgetting their PIN. And that one becomes its own microservice. And then we wanted to add in a topic for requesting a bank statement, and that would become its own microservice. So we had a one-to-one mapping between a binary classifier and a Python microservice. The rest of the Monzo infrastructure is written in Go. And so effectively, we had a Go orchestrator service, which will receive the text from the customer when the customer has stopped typing. It will send that text out to all three of the different classifiers and get back their predictions. And then it will pick which one is the winner. The way that it would pick the winner is extremely simple. It would just return the topic from the binary classifier that had the highest inference probability. So a few reflections on this. This allowed me to distribute the work into my team, because then one person in my team could take classifier A and work on it, iterate on it, improve it. Another person could take classifier B. And then once we had a new topic in place, someone could just add it into the system and just plug it into the orchestrator and set it in shadow mode so that it was there, it was making predictions, but that topic was just not a candidate because it was in early evaluation mode. And then finally, the biggest wins that we added here that were outside of the machine learning modeling space was that we used a bunch of rules that would also govern the behavior of the classifiers. I'll give you a very simple example. If a customer has lost their card, they would get in touch and request a new one. And it was not unlikely that those customers would then get in touch again and then say, oh, by the way, I've moved house, or oh, by the way, like, where is my card? It's been more than a few days, and I'm still expecting it. So one of the rules that we paired with this card replacement classifier was looking at, is there an active card order already for this customer? Just to avoid the classifier being the winner and the customer trying to order a second card when they already have one on the way. That was an example of the type of problem that was much easier to solve in the system, not using machine learning, rather than try and tweak the data and tweak the models even further. So that's the overview of the system. Where this is today, I'm just coming on half an hour, so I'll just wrap up here. there was a big movement inside the company around is this chatbot the sort of right interaction style that we wanted with our customers. And one of the outcomes from there is that there are a number of queries that customers will ask us that actually take a very structured approach. So a simple example could be a customer expecting a refund on a particular transaction that they have made. And so they would say, hey, I'm expecting a refund. And the agent would say, okay, which transaction? And they would say, the one from Tuesday at 9 a.m. at this shop. And there was a big back and forth where the agent was actually collecting information in a very structured way. And I am aware that there is research on conversational agents to enable this sort of stuff, but ultimately it was easier and faster for us to start developing interactive forms where the customers can put this information in. And so right now we have disabled the bot. And instead, what we are using this same architecture for is that when customers do get in touch, we run them through all the same classifiers and use that classification outcome to contribute to another system that decides which is the best agent for you to talk to right now. So again, another example of repurposing an existing ML system rather than having to rebuild it from scratch. So yeah, that's the overview. I put some links to some detailed blog posts on these topics that I have covered today, and you can find me online on Twitter, Neal_Lathia, and always happy to chat more about this stuff. But be happy to take your questions now too.
And definitely follow Neal and check his blog. It's awesome. So when is the next article coming?
Yeah, I guess you called me out now. Last year, I did ramp up blogging a bit because I was locked up at home so much. So hopefully soon.
Okay. Yeah, so there is a question like, will you publish your presentation video? So definitely video will be uploaded to our YouTube channel, and I assume you will share the presentation in Slack.
Yeah,
right?
I'll do.
Okay, so then we have a question, like when you were showing this screen with data labeling tool. Did I understand correctly that this data labeling, you did this yourself, your team did?
Yes.
So you didn't outsource it to Mechanical
Yeah.
Turk or anything?
We did it ourselves for a few reasons. Number one, it's extremely confidential data. It would be very hard to remove any personally identifiable information from it. And then the second point is that one that I learned by doing this data labeling, I got a lot of insight into the data myself by labeling the data. And there are many different nuances that you pick up by exploring the data yourself. And I found that there was a benefit to this. A very silly example was we would have customers saying, I need a bank statement for Visa. And I was always wondering, what are they going on about? Because our cards are MasterCard, they're not Visa. And I was like, how are, what's going on here? In practice, this was customers asking for a bank statement because they were applying for a visa to travel to another country, right? And they just didn't specify that. So there were so many ins and outs of these that we learned. I guess this is also testament to getting like real live production data from people who may not be mother tongue English, as opposed to curated data sets from that are in English, and you don't have all these strange nuances. So we learned a lot about how customers were speaking to us. And then we also learned a lot about how our agents were tagging the topics and where some of these topics were being interpreted in different ways by agents, like the update details example I mentioned earlier.
Yeah, definitely. Now, when you say, I can totally relate to that, and like labeling data ourselves gives this insight that you wouldn't get otherwise. What are some of the internal frameworks that data scientists use in your team to speed up their work?
Yeah, that's a great question. So we use, so in all of data science, our primary stack is BigQuery and SQL and DBT, or data build tool, for managing all the crazy amounts of SQL that we write. So a lot of our analytic reporting queries are written using DBT, then are scheduled to run daily or so with Airflow. And every time they run, they're just running a query on BigQuery. And those insights then get surfaced in Looker. So what are the differences with ML? For training these ML models, there's a lot more experimentation. There's a lot more ad hoc work that needs to be done. But one of the things that was common across all of this language modeling type of work was our need to be able to build, construct well-cleaned supervised learning data sets. So one of the pipelines that we built is one that our machine learning team uses, where you can run the pipeline yourself and you point it to what label you want it to extract. And it does the entire process of constructing that data set for you. An example of that is in my slides, I mentioned this concept of turns. So the customer could write several messages, then the agent can respond with several messages. And we didn't want to be rewriting the logic to combine all of those messages into a single piece of text over and over again. So all of my team would be using this common data set creation tool. And if they found strange bugs in it, it would fix it for everybody. And then we had a similar pipeline for fine-tuning BERT classifiers and trying out different language models from Hugging Face. And we would run that on the Google AI platform, which is effectively a way to submit Docker containers that run some ML code, and you can specify what type of machine they need to run on. So I've covered analytics, I've covered model training. The final bit, which I mentioned I wouldn't go too much into detail, is the production side. And so we have a brilliant platform team that runs our Kubernetes cluster. So the level of abstraction that my team needs to think about is more about shipping microservices. And we, in the earliest days when I joined Monzo, we decided to add Python into the mix there, because we didn't want to be rewriting ML libraries and translating them into Go. But Go remains the mother tongue of the Monzo backend. And so where possible, we write stuff in Go. And we try to keep our Python services as lightweight as possible.
So your team also writes in Go? Or okay.
Yeah, it's not something that we required when hiring for the team, but nearly everyone in my team has become very proficient in Go. It gives us a greater autonomy, and then also it allows us to understand other teams' code as well. So I like to think that, Python and Go are not too dissimilar. It's not like, say, Java and Python, but so they're kind of close, maybe in some sort of coding embedding space, and that if you've done some Python, then moving into Go is not a very long journey.
Okay. So basically, your Python services are quite simple. I assume it's something like a Flask app or something similar like that,
Yeah.
that just gets a request and does the processing and gives back the response, right?
Actually, that's a good point. We try even to not do pre-processing in the Python service.
Oh, okay.
We try to just do the basically the model predict in the Python service.
Okay.
The reason for that is that then if we have to do any pre-processing, and this is going more towards the areas where we ship more classical sort of random forest type of models, where there's tabular input, it's by writing that pre-processing step in Go, it can be maintained by nearly anybody in the company, because all of our backend engineers know that language. So it kind of reduces the risk on the team where otherwise the machine learning services start becoming a little bit of a black box to backend engineers who've had no exposure to ML before.
Okay, so you basically keep Python services as simple as possible. So if something happens, then a backend engineer can just jump in and figure out immediately what's going on and fix
exactly.
it. Okay. Yeah, thanks. Are the binary classifiers that you assembled in the microservices approach still BERT models, or you use something else to reduce the complexity?
Yeah, they're still BERT models. One of the things that I didn't put into the slide deck, probably should have mentioned, is that once all of the sprinting to get this into production had quietened down a little bit, we did backtrack and say, did we make the right decision? Would a one single multi-class have been a better approach? And so we spent some time training a huge multi-class model, and it was, if I remember correctly, put into shadow mode as well, and it was evaluated against this series of binary classifiers, and it did slightly worse. And obviously, that's a very easy way to summarize what under the hood is a multi-class model, where you know slightly better on some topics, much worse on some, and it becomes a little bit more tricky to reason about. But they're still all BERT models, and the only thing that we've, in terms of deploying other types of machine learning, if we're shipping a BERT model, it's usually going to just be one BERT model in a Python service, because they are fairly large. And whereas if we are shipping, for example, a scikit-learn random forest, we could prospectively put several models into one microservice, where those several models are the current winner and the shadow models, the sort of challenger models that we are evaluating.
Okay. And these BERT models, they're like just full, let's say, BERT, or some sort of distilled BERT models? Like, did
Yeah,
you?
it's just the BERT base uncased.
It's huge, right?
It is pretty huge, but actually it's overall, especially in the context of chatbots, there weren't too many worries in terms of shipping this. Inference time was still in the order of like 100 to 200 milliseconds, and that is already like at the speed of light for a chatbot. You actually maybe want your chatbot to be slower than that, because if it's answering too fast, then it's like a bad customer experience. And then in terms of the model size itself, you know, we scaled up the pods and didn't see any huge problems with it.
So since you said it's like 100 to 100 milliseconds, I assume you use GPUs, right?
No, actually, we were using CPUs for inference. Okay. I said, yeah, it was about 200 milliseconds. I think for this multi-class model, that's when things got a bit slower, but still, I think in the context of a human expecting a response, I think the tolerance there is like 5 to 10 seconds, right? And so, yeah, you don't need a BERT model to be sort of running at the speed of light, and especially for customer service.
Makes sense. And did you do any like tricks? Like I know, like when you want to deploy a deep learning model, they work better when you send, let's say, a batch of 10, 20 examples, not just one by one. Did you do anything like that, or you just send, okay, somebody typed it, you send it, you have a batch of one, and you just process it?
Yeah, that's
Okay.
right. There are other models that where we batch things up, but they aren't the customer-facing ones. So, for example, there are now, more recently, some language models that we use to analyze the conversations. So we've done some early experiments with sentiment, nothing definitive there yet. But one of the things that we wanted to do was look at how quickly conversations are being resolved. And that is a combination of a metric that has been hard-coded plus some inference about different parts of the conversation. Since the main output of that is a dashboard for reporting, then we run that as a daily batch process over the however many thousands of conversations that will have happened that day.
Yeah, makes sense. And we have two related questions. So one is, how do you update your classifiers, one at a time or all at the same time? And the other one is, how do you experiment in this setup? When you want to update the classifier A, how do you test it, shadow testing or something else?
So usually we will be updating them one at a time. I'm very scared of these big changes where we change everything. So what we had, and this is actually an area that we will need to improve again soon, was these models are making their predictions, and then a certain percentage of those predictions get turned into data labeling tasks. And then we would manually go through the data labeling tasks, and the metrics from those would get surfaced on a dashboard. So we'd be able to see which models seem to be degrading in performance. One of the tweaks that we added in there was to try and only label things that we had never labeled before. So once you label a specific input from the customer and you see that input 3 times and you've labeled it 3 times, then humans don't need to label it anymore. So when we would see certain models degrading, we would usually, if they were really bad, we would just turn them off right away, rather not give an answer than give a bad answer. And then in terms of retraining it, usually we would go through the same process. So put it into shadow mode, verify that the metrics are up again. And I guess the one question that it becomes company specific is where your comfort threshold is in terms of what performance you're seeing online. There's no sort of perfect answer here, but if you're online, if you're expecting your model to be 99% accurate online, then you're never going to turn on any models, right? But clearly there needs to be some sort of bound there. So usually, as a rule of thumb, we were looking in the high 80s, early 90s in terms of precision. In these cases, we would give much more weight towards precision-oriented metrics rather than any kind of recall metrics. Again, because we wanted, when we gave an answer, we wanted it to be the right answer.
Yeah, makes sense. And so just to make sure I understood you correctly, because you mentioned an interesting point about model degradation. So as I understood, so models are live, they're working, and then you just sample the answers from the model. And then a human labeler looks at these answers and then classifies, okay, this was correct, this was not correct, and then you just put these things on the dashboard.
Yep, that's right.
And then you can see, okay, like this model is actually doing worse. Like it used to be like 90% accurate. Now it's 80. Let's retrain it, right?
Yep, yep.
Okay.
So for those language models, it was like that, and it was on a per topic basis. For the more tabular oriented ML models, we'll typically be starting from higher level product metrics. So looking at, for example, a fraud classifier, is it able to continue catching the same amount of fraud that it was always catching? And if that seems to not be going in the right direction, then usually the first thing to do is retrain the model. Usually by that point, we would already have several challenger models kind of lined up. So I guess this speaks to whether, when it comes to online model monitoring and model drift, whether you want to be kind of reactive and so trying to figure out when should I retrain a model, or proactive and kind of always train a new one, put it in there in shadow mode, and always have a more recent one kind of ready to go. This will vary obviously by whether that system is currently important to your team and to the rest of the business, because you clearly can't do this for every single system that you have out there.
But from what I understood, the process of retraining a model is relatively simple.
Yes.
You have all these pipelines, so for you, you can just retrain them, let's say, I don't know, every week, and just roll it out.
Yeah. The one area where we haven't reached, which I know other companies have, is we still look at the numbers manually to decide to actually turn it on. We haven't ever done any like automated train and deploy.
Yeah, look, sounds a bit scary, right?
Yeah, yeah, exactly. Like, you know, you just accidentally do some crazy overfit and then it auto deploys. Yeah, it definitely would keep me up at night if for that sort of risk to happen.
Then we have a question from not an expert in language models. So did you use BERT to create features from the chat and ship them to the binary classifiers, or each classifier is the whole model?
That is actually a really good question, because we discussed that. So in this case, we shipped each classifier is the whole BERT network, and I guess the point of debate there is, again, trading off between the architecture of the system, because, for example, you could ship the tail or the first however many layers of the network as one service that just encodes everything, and then to each individual classifier. But in this case, we felt that that would cause a big dependence between these different systems. And also, when we were fine-tuning the model, we were fine-tuning it all the way back to the beginning. So this gave us quite a lot of flexibility. I will mention that this is an approach that we have taken in other areas. So we have done some early experiments with detecting poor quality images that customers take. And there, the constraints were the other way around, in that we, a lot of the images that customers will upload are highly sensitive, like documents and stuff. So we don't have direct access to them. And we can't just sort of download a batch of images to train a model with. So in that case, we shipped a service that was just the pre-trained part of the network, and then it would log data about the embeddings for each image, and then we would train new models just on those embeddings. So I think this is kind of a broadly unsolved challenge in ML engineering. I haven't seen too many great examples of this. Maybe the one example that I've seen is the talks from Tesla, where they were doing crazy multi-head, multitask learning. And there's some great talks about that online too. You lost your electricity.
Yeah, my son is playing with my. Okay, now it's back. Yeah. So there is a question: if you have in-house data annotators apart from your team or not?
We have only done one-off projects with the customer service team to get them to annotate data for us. It's not a regular thing, but it's something that I think is achievable. But you really need to be able to sell the value to whoever else. And I think the value there is telling them like, look, if you help me to annotate this data, then we'll get this model out and it'll be so much better. And doing it the first time is the hardest time, because then the second time you'd be like, hey, remember that time that you helped me label some data and we got that model out and it was great? Like if you help me do it again. So obviously the primary function of our customer support team is to talk to customers and not to label data for the ML team. But they have done these one-off projects with us.
But like speaking of this degradation performance, and we talked about manual analysis. So if it's your team doing, how does it look like? So you wake up, I don't know, get some coffee, sit up in front of your computer, and then start going through the answers, label, and then you have these things on the dashboard, or?
Yeah. So we built this using the same tooling that our agents use to talk to customers. So the Monzo systems have this concept of like creating a task in the system and adding that task to a specific queue. And so that's the one side of our labeling system, which is creating these tasks and adding them into the machine learning queue. And then back while we were doing this project, we would schedule 1 hour a week in as a team thing. It was pre-pandemic, so we were all in the office together, and we say, okay, as you said, grab some coffee, let's label some stuff for an hour. You'd be surprised how much you can label within 3 people in an hour. You can do loads. And then that data, every time we would submit, that data just would get logged as well and go into our analytics stack so that then it could get munched together for the dashboards. The one interesting thing that we would have is we would always have a little Slack thread while we were labeling stuff where we would talk about the really ambiguous cases. And again, this led us to quite a lot of insight into the data itself.
Okay, thanks. We have 2 more questions. Do you have time to?
Yeah, go for it. Yeah.
Yeah, thanks. So when your team is building a classifier, are they allowed to share features and approaches, or they're kept separate so they don't find similar solutions?
So I did see that one of your future talks is about feature stores.
Yes.
In the end of last year, we built our own feature store as well. This is again more for the tabular flavor of models, and now there are tens, if not close to 100 different features in this feature store, and usually we encourage sharing features as much as possible, but sharing features within the same family of problems. So like fraud detection, we will share a lot of features between models there. The best insight that I get from my team is when one person says, hey, I tried this feature on my model and it really worked. And maybe another person says, hey, I tried this feature and it didn't work. But in ML, especially, the negative result is nearly as important as the positive one. So when it comes to text, since we're just sort of throwing text into these huge models, there's less about sharing features across models. It's just throw the text all over the place.
Yeah, so there is a question: does feature store make sense for NLP or text classification tasks?
So rather than a feature store in the like current popular framing of a feature store, which I mean, I'm aware that there are several different of these framings, but broadly, our feature store is a way to bridge between our analytics, where we do a lot of feature engineering, and our production, where we want to make predictions using different features. For text data, the hardest problem, where we have a service that is entirely dedicated to solving this problem, is to create representations of conversations that are relevant to a machine learning model. So in that case, it's solving problems like identifying the turns in the conversation, removing automated messages from the conversation, removing screenshots and replacing them with a token that means that the customer has uploaded a screenshot. What else? All of these sorts of things. When we launched the bot that I showed you, there were buttons on that screen where the customer would say, yes, I found what I'm looking for, or no. And all of these were needed to be somehow represented in the data as well, whether for training other models or for the reporting. So we have a feature store in the sense that we can say, hey, for this conversation, give me the first turn, give me the second turn, or give me the entire conversation. And that's sort of the level of abstraction that we need in terms of being able to plug it into a language model.
Okay, makes sense. And the last question that we have is, do you need to handle any other languages than English?
Right now, Monzo is just in the UK, and so the language that our customer support provides is just in English. That doesn't mean that customers don't write to us in other languages. And so, but what has happened so far is we have mostly been trying to detect the usage of other languages, because then we disable these types of prompts, or we would just use it for analytics. I mean, it's kind of a tricky one, because if a customer writes to us in Spanish, for example, or in German or in Italian, then the automated messages we can provide would make no sense to them anyway. And then they would need to get through to a customer service agent who would also need to try and find a way to communicate with this customer. I don't know how they do it, actually. So yeah, long way to say that we don't have multi-language support, but that doesn't mean customers don't write to us in their own language.
Okay, so they write, and then maybe the agents, they use Google Translate or something else.
Yeah.
Or maybe they just happen to speak the language.
Yeah, I have definitely seen some call outs on Slack. Hey, does anyone speak this language? We have a customer who's talking to us, and people will jump in and help them.
Mm-hmm. Yeah, that's all the questions we have. So thanks a lot
Awesome.
for your time.
That was a great set of questions. Thanks to everyone.
Yes, thanks for sharing your experience, your knowledge with us, for answering all these questions, and thanks everyone for attending today. Yeah. So just a reminder, we have one more session on Thursday and one more on Friday. So don't forget to check them. Okay.
Awesome.
Well, have a good evening.
Bye, everyone.
Goodbye.